Good afternoon. This is Desmond Martin, Program Coordinator at NextWave STEM, and I would like to thank you so much for joining us for today's webinar. NextWave STEM, we have been conducting this series of webinars since the pandemic began back in late March, and we are really excited to talk about hybrid learning, what that might mean for a really dynamic learning model for your students this fall. But we also recognize that it is a weird time, to not put too fine a point on it. We understand that many of you are still trying to figure out what this fall actually will look like, what your priorities will be as educators, what your students need, both emotionally, both physically, and thinking about their instruction and their education. The primary reason that we at NextWave STEM are conducting these webinars is to hopefully be a resource. We're hoping that just from a little bit of our insight and what we've been doing through the course of the past few years in STEM education, and what we've seen throughout the course of the summer as all of us have had to pivot and learn new skill sets and try different things and reach out to student populations in some innovative ways. We're hoping that we can take some of these lessons and that they would be applicable for you. So while this is a webinar, it's more kind of like a conversation. One note on that, and that's why this is the part where we'll cover the house rules today. We are in webinar mode. That just means that while I know your camera ready, I know that you look fabulous and that you've got the most beautiful sonorous voice, we won't be able to see your face or hear your voice today. We are in webinar mode. That, however, does not mean that you don't have a voice. You are more than welcome to join in the chat or in the question and answer functionality here on Zoom. When we started our webinar series, I know that many of us were still really practicing and learning more and more about what we might be able to do in order to get better at our digital tools. At this point, I'm sure that we're probably all Zoom masters. So drop your comments in the chat. If you're not familiar with where the chat is, I'm going to drop a little message now, and you should have a notification pop up. The Q&A is also open. If there's a question that you want to pose, but you want to keep it anonymous, I will also be answering your questions in the Q&A. That's the first bit of housekeeping. The second bit of housekeeping is that we are recording today's session. That means that if you need to step away, if there's a pressing issue, then no worries whatsoever. We will be able to make this recording available to you after the call today. You'll be receiving an email that has a link to this recording on the NextWave STEM YouTube channel. Additionally, for our Illinois educators, thank you so much for joining us. You're home folks, as we like to say. We are based out of Chicago. It is really exciting to have you. And since you're with us, for today's webinar is actually 1 hour PD credit. That email that has a link to the recording of today's webinar will also have the documentation in order for you to submit your PD hour to ISB. So you will get that proof of attendance. For those of us who are joining from outside of Illinois, we love you guys so much. Currently, we do not have PD participation partnerships outside of the state of Illinois, but that's something that we're working on, and we love to make that available in the future. However, we will be sending that proof of attendance to you as well, just in case you just need that documentation for your particular situation. I think those are all the housekeeping items that we need to dig into. So we will go ahead and jump right into it. And a great place to begin is right at the beginning. NextWave STEM has been a company that's been really instrumental to my personal development and professional development. Once again, for those of us who just joined, my name is Desmond Martin. I'm the program coordinator at NextWave STEM. And before I got into the STEM space, I was actually a mechanical engineer by profession and by training. What we have recognized in the field of engineering for years and years is that there are not enough of us, point blank period. The world requires complex problem solving, There are massive, massive issues all around us. We don't have to mention a global pandemic. There are engineers and doctors, medical professionals all over the world working day and night to try to figure out some real solutions, some of them common sense, some of them very high tech. We have issues of food shortages. Climate change is real, it's here. We see climate refugees here in the United States. Just over the course of the summer, we've seen catastrophic damage done by wildfires in California. We believe that some of these problems are large, some of them are much, much smaller and localized, but we think that there are solutions to all of these problems that can be garnered from STEM professionals, from scientists, technologists, engineers, and mathematicians. And we understand that in order to get more of those professionals into the field solving these problems, we're going to need you. We're going to need educators from all over the world, all over the United States to introduce students to STEM fields. It's critical. And the more and more students are able to integrate, to feel like they belong, to know that they can make mistakes, pick themselves up or be picked up by their peers and instructors and succeed, it is critical that our educators are walking that path with them. Mary is in the chat right now. Mary Desharm, who has been with us so often. Hey, Mary, thanks so much for being with us. Mary says that Bill Nye, the science guy, says that we have to catch students by at least 5th grade in order to inspire them for science and math careers. And I would absolutely agree. Many of us are working at the high school level or maybe even the upper elementary level, and that work is so critical and so great. We are big advocates here at NextWave STEM of capturing students as young as we can. So that's why at NextWave STEM we provide K through 12 curricula and emerging technologies, drones, computers, and artificial intelligence, robotics, and 3D printing. These are some of the emerging technologies that we're providing courses for and that we really are here to support our teachers with. When we think about curricula, when we think about actual training for the technology and in the particular curricula and the equipment. We like to think of ourselves as a one-stop shop so that you can be the kind of educator that provides confidence for the students at the kindergarten level, all the way up to the high school level, so that we can see some of those STEM outcomes and solve some of those really, really tough problems that we see in the world around us. So now that we've covered a little bit about who we are in NextWave STEM, it's useful to take a step back and think about our goals for our time today. And we have 2 major objectives. The first is that we want to explore the ways STEM courses can be delivered both in person and remotely. This becomes really, really interesting for our particular context now because of COVID and how often we may be in remote teaching or in hybrid situations. We want to think about curricular planning that helps us accomplish really effective instructor in both scenarios. The second thing we want to do is develop a framework for planning that provides options. It's one thing to have a plan that works really well remotely. It's one thing to have a plan that works really well at a distance. But it's hard to have something that you can pivot in between two, granted that we don't know exactly what the future holds. One thing that many scientists and epidemiologists are professionals who are working all throughout public health are concerned about is a second wave of infections here in the United States. If that should happen, we want to be prepared and make sure that your curricular planning is prepared as well. So the first thing we want to do is explore what exactly we mean by the hybrid learning model. We are in full swing back to school now for at least 5 or maybe even 6 weeks, depending on where you're from. Don't be afraid to drop in the chat where you're from and what you teach so that we can get a better idea who we have with us. But if you've been going for a while now, there's a decent chance that you've been working in a hybrid learning model, and it may look something like what we're about to see. So when we think about the hybrid learning model, and this is something that many of you already know, what we want to do is prioritize staff and student wellness first and foremost. We want to make sure that you are safe and that your students are safe when you learn. The second thing is we want to create high quality learning experience for all students. One thing that can get overlooked and oftentimes, unfortunately, really does go overlooked is for our high needs populations. When we think about our kindergartners, our high schoolers, our special ed students, our vocational students, sometimes they can be left behind when we think about remote instruction. And we have to think about how we can make those resources available to them as much as we can so that they can get as much out of their educational opportunities. Uh, and then we want to really think about creating curricular opportunities around these populations. How does it continue to keep you and your students safe? How is it high quality? And how does it support our learning populations that are really high needs? So the first step is to think about your specific STEM learning goals. Many of us are still really figuring out what our core subject matter may look at. You understand that STEM education is a completely shifted and mixed bag. Some of you all are dedicated science teachers with your science education certification. Um, and that is awesome because you all have already been teaching STEM and now you have to make a bit of an adjustment. Some of you may be technology teachers, and now that means that you're taking on the extra hat. Some of you may be the math teacher who's taking on the extra hat. Some of you may be an out of school time, after school coach or club leader. So you're taking on that extra hat on top of that. It's important to be clear about what you want to actually accomplish in your STEM curricula. What are our overarching goals? Mary with a really good comment here. G Suite tools, equations, read and write for those with disabilities, making sure that those digital tools are set up. Many of us have been in many professional developments for our digital tools, whether that's G Suite and Google Classroom, Office 365, Zoom, Google Meet, using things like Canva or Blackboard. We are growing all of our skills, and many of us teaching in ways that we have never taught before and maybe never would have imagined we would teach. Our goals may be involved in making sure that we're using all of our digital tools effectively and teaching our students more about how those digital tools work. Once we clarify those goals, we have a good starting point. So the first place to start is to actually plan out our learning objectives and think about our standards alignments. This can be really, really difficult. This can be difficult for a bunch of different reasons. If for no other reason, then we're still figuring out in a lot of states and a lot of jurisdictions, a lot of scenarios, what our actual assessment and standardized testing situations going to look like. And that can be really, really hard right now. That tends to push a lot of our instructional priority to those core subject areas when we think about reading and mathematics. And that makes sense. I'm not going to blame anybody. Those are the circumstances and situations that we have. But we don't want to throw the baby out of the bathwater. So it's important that we can collaborate with our administration, with our other faculty, so that two things happen. One, which many of you are already doing really well, is making sure that your teaching methods are actually in alignment and are similar for your students across your actual instructional sessions. And that's important because while you're putting your own flair and twist and bringing your personality and make it engaging for your students, which is really difficult to do remotely, you're also creating and setting expectations for your students, for your parents who you've been partnering with more and more, and making it easier for your students to adapt to this change. I know students have been going stir crazy. Things that we have been expecting with respect to the football season and basketball season and pep rallies and field trips and school spirit days. Those things have been put on pause right now. So it's very difficult sometimes for our students to feel like they're really involved with their classrooms. Making sure that there's a consistency of engagement, ways to engage, ways to use your tools to be connected is really important. The second thing that's really important is to kind of dig into the bag a little bit and realize that STEM, science, technology, engineering, and mathematics, are great ways, really, really good ways to do some cross-curricular connections. Things that you do in your STEM courses will actually correspond to what's going on in next generation science standards, ISTE standards, Common Core Math, Common Core Reading. They don't have to be one or the other, they can be both. And as you're collaborating with your other faculty members, you can select lessons and select curricula that really can support each other. Finding ways that Common Core Reading will support what you're doing in your STEM activities, finding STEM activities that support what your students are doing in your math instruction, makes this really cohesive and builds something that helps to make the STEM experience real for your students so that they understand application. All of this is not easy to do remotely, but this is something that we can leverage to our advantage. Androgyny, yes, important, or coaching parents, absolutely. Our parent expectations, and this is kind of where we have this double-edged swords, where because we're remote, because for many of our students, in fact, most of our students now, their classrooms are their homes. The parents are there with them as well. Their whole mindset has had to shift dramatically, and their expectations will have to change as well, understanding that they can see intimately how the preparation plays out for your instruction with your students, especially if you're dealing with a difficult student population. It becomes a really powerful way to bridge the parent community into what you're doing. So they become a vital part of the team as well when we think about bringing STEM into the classroom. The overarching theme here is that as long as we're working with concepts and technology that can bridge core subject areas, STEM becomes a huge value add. So today we're going to focus on two technologies. I mentioned 4 technologies that we work with here at NextWave STEM, and that's really critical for us because we really want to give our learners a diverse opportunity with which to understand science and technology. We're focusing on 2 today because 1, they're really, really exciting for students, and 2, they lend themselves really well to hybrid learning into various modalities, both in person and remotely. Those 2 technologies are drones and 3D printing. So I'll kind of segment them. We'll talk about drones first, and then we'll talk about 3D printing. When we work with drones, whether this is kindergarten through 2nd grade, 3 through 5, 6 through 8, or 9 through 12 drone curricula at NextWave STEM, we're focusing on some major principles, ideas in computer science, basically coding, mathematics and engineering, problem solving using this technology are really evident and really core of what happens in all those curricula. Students will practice programming, they'll be simulating actual flight, and they'll actually think about application, what we will use this drone to accomplish. That's really critical. And the way that we are able to connect what we do in simulation and abstraction and programming is to connect to the physical drone and fly a drone, not with a control stick, but actually autonomously, letting the computer programming do the work for the actual pilot in that situation. When you think about 3D printing, this becomes a much different paradigm with which students have to focus. Students are learning skills in computer-aided design, but they're also focusing on the engineering design process, really solving problems through the designing a physical object that solves this problem. That really requires them to put their thinking hats on. And that becomes a great way for 3 through 5, 6 through 8, and 9 through 12 students to engage. So when we 3D print, what we're actually doing is allowing our students to design physical objects and modify physical objects through cloud-based design software. That means that they are able to actually log on to their computers just as long as they have internet connection and design. They'll work through that engineering design process that I mentioned before which is something that we as professional engineers use all the time. And then we're able to connect to remote printing services. If a student doesn't have access to a 3D printer, you might not have a 3D printer at the school or might not have the staff to be able to effectively run a 3D printer. You can access remote services to print and deliver your objects. But that big payoff, once again, becomes the opportunity, if you have a 3D printer, to connect the designs, to download those designs, transfer them to your printer, and physically print what your students have been designing. So once we have this idea, kind of having our technologies, thinking about where these technologies will connect to our core principles, thinking about how the technologies, once they connect to our core principles, can be really useful to our other colleagues doing work in their other classrooms, how this supports math and reading learning. It becomes important for us to then build a framework with which we think about hybrid learning. And this is more about flexibility. Before I jump into this, hey, Lay, thank you so much for joining us from Maryland. I've got some family out that way in Prince George's County. Thank you so much for joining us. So it's really important to think about our hybrid instructional scenarios. You guys have been in your virtual staff meetings or maybe even your in-person staff meetings talking about this a lot. You've been getting updated at the district level. You have been reading things on the news from the CDC, just trying to figure out, okay, where are we going to be at? What can we hope for our students? When are they going to let us know? And the way that we are considering hybrid learning is really distilled down to 3 scenarios. There are different ways that these scenarios can get rejiggered, for lack of a better description. In some school districts have 3 scenarios, some have 5. It really all boils down to these 3 scenarios. The first is what we call a surge of infections. This assumes that we get to a place in the future where transmission rate is low enough, the population is for all intents and purposes, safe. But we haven't completely suppressed the spread of the virus. That will put us in a situation where we are learning at school, and then we would have to transition back into remote learning. This is similar to the hybrid instructional model, but we'll talk about that a little bit differently. In the not ready to return scenario, where many of us currently are, if we're not doing hybrid learning, we are exactly that, completely remotely, working through our curricula. And then at some point in the future, maybe it's the next scenario or next semester, maybe it's the next year, we make this turn so that we are back to our traditional instructional models. And then we may find ourselves in good old fashioned, well, good new fashion, as it were, hybrid instruction, where we're learning at school, we're learning at home, and then we're learning back at school, where we may be shifting populations. So we have an A block and a B block on certain days. There's virtual instruction going on and remote work going on during the middle of all this. Depending on what your situation for instruction may be, this will differ for state to state, district to district. It's important to have some flexibility because you may find yourself in a scenario where you're working through the curriculum with your goals in mind and your actual instructional model, the logistics may change dramatically. Mary, dropping in some gems here in our chat. Rehab Engineering Society of North America is going to have ideas animated and simulated, not actual lab work for next year's conference because of little lab time. Absolutely, we've seen this idea working out with robotics. Robotics simulation and planning has become really important. We're seeing animators, graphical designers, those who have those really good skills in simulation being snapped up all over the place. It is becoming critical that we learn more how to do some cloud work right now. Science fairs could use the same ideas. So if a school has as much hands-on time as possible. This is quite possibly something that we may see happening. Longitudinal work with students becomes more digital. Project-based learning becomes a lot more viable in this scenario if we're really effective at coaching our students through project-based learning. And NextWave STEM in our 9 through 12 drones course that's been newly designed for this fall semester, we actually include a project-based learning capstone for students. So once they get those basic coding and drone safety skills and even simulate to abstract tasks, they're able to jump in and then solve a real world problem over some time. That's something we're really excited to see placed into action. Really good points there. I'm excited. I'm going to check that out, Mary. So it's important, this idea of being in a place where our instructional scenarios may change really makes it important that we have flexibility in our curricula. There are ways to think about that. A lot of scenarios, schools may say, okay, we're going to pick something for our scenario. And if our scenario changes, we drop or do something completely differently. I'm of the opinion that creates a really disjointed experience, throws our learning objectives out of the window. Instead, it's important to think about curricula that will flex to what we have going on. So what we have bullet pointed here is this idea of our particular scenario and how our curriculum allows us to flex in between them. When we're working with drones, if we find a surge of infections, that situation where we're at school and then have to be remote for some extended amount of time, in the school situation, we're coding and flying in groups, running our curricula as per usual as we would in a normal classroom. The school community gets to fly at the school and is able to engage. But if we're moved remotely, we find ourselves in a situation where we're able to still code and work through the computer science components of our curricula while simulating those flight scenarios. We don't throw the whole thing out of the window. Our students are still able to engage. If we flip that, we think about the not ready to return scenario, where many of us are at right now. We're remote, and then we have to come back. We're kind of turning that on its head. Simulated, working through scenarios, learning about computer programming remotely in the cloud first. And then when we come back to school, if our students don't have access to the drone at home, many of them won't if we don't make that available to them. As they come back to school, then we're doing the work they were doing on their computers, connecting that to the drone, and then running our code through our drone. Our school comes to life with drone flight as we get back and we're able to connect the technology, the hands-on work to the digital work that students are doing. And then when we find the hybrid scenario, we're able to connect coding basics to physical safety protocols. How are we safely using the drone? How are we learning code for the first time? How are we applying that? If this is your student's first time as a third grader working with computer science, their first time working with Scratch as our programming language, how are they effectively able to give a machine instructions? That hybrid scenario may involve the remote work of actual program preparation, where they are solving the problem on their own with the guidance and instruction that you've given them in your in-person or virtualized instructional time. And then when they come back to school, they're connecting to the drone. So we've got this handoff idea of instruction, preparation, that's remote, coming back to school, and then physical flight. It's a much more condensed idea of what's happening in the not ready to return, just in a cycled way. So we can already build in and see how this might actually physically work, especially when we're in consultation and collaboration with our other faculty and administration members. And the same idea actually holds true when we think about being flexible in 3D printing. Mary and I, we've been in these webinar series quite a bit, and we've talked about some of the amazing things going on in the disability community with 3D printing. Being flexible, having situations where we may have students doing remote work and then coming in person, allows for some longitudinal exploration and really great opportunities to learn more about design and design tools. In this case, our particular design tool in Tinkercad, which is extremely accessible. Uh, so in our first scenario, in the surgeon instructions, once again, where we're at school and then our students are going home. Students are in person with you building their CAD, their computer aided design skills, and they're initiating the engineering design process. They're understanding problems, they're doing research, they may even start ideating and getting into the design solutions. Really depends on how things shake out with where you start and where the unfortunate change might occur. When we get remote, we're thinking about virtual instruction towards those engineering goals and delivery of the finished project. Something that Mary mentioned a little bit earlier, we may even have the opportunity to simulate the efficacy of the object in solving our problems. Can we, for example, using augmented reality, take a 3D object and see if it actually would fit into the area in which we've designed it to fit? That becomes a really, really powerful way for our students to experience what they're doing digitally in the real world. In the not ready to return scenario, we find ourselves where we are now at home and really eagerly awaiting those students' return. A virtual instruction is pushing students towards their engineering goals. We have to teach them how to use the design tool, in this case, Tinkercad, remotely. Through screen share, being really good with our technology, allowing them to participate, integrating in Google Classroom. And then we get to the point where we're teaching them how to slice. That's a little bit in the weeds when we think about 3D printing. If you've never done any kind of 3D printing before, you can think about 3D printing as actually a 3-step process. And no matter what your design software is, no matter what your 3D printer is, you'll always follow these 3 steps. The first is to design, where you go from scratch, or maybe you download something someone else has designed and you modify, but that's taking in raw math this 3-dimensional object. That's the part where we sketch up what we're doing and we get our final plan. Or the final idea for what our plan should look like. The second step is slicing. 3D printers are like cars. There are hundreds of different brands, and at this point, probably thousands of different models of 3D printers. And they all operate a little bit differently. But the slicing software allows that raw 3D design of that object you took to be translated into something your 3D printer can understand. Our students are able to do that remotely with free software that they can download to their computers, with software that even exists in the cloud. Once again, all they need is an internet connection and they're able to slice for a 3D printer, even your 3D printer that you may have in your school. And then at the point where we are able to come back to school, we're connecting those 3D prints, those 3D printing files to our 3D printer, and we're able to print them and we're able to test them. In the hybrid instructional model, we're kind of taking those ideas and we're flipping them and flopping them based on where we are at with our students physically. Computer aided design and skill building, that initiation of the engineering design process can happen in person, where our students are able to collaborate in person, really working together, doing things like whiteboarding and sketching, post-it noting, really fun. The progress of design, the actual hard skills building, practice and mastery of the skills, ideation of the engineering solution, even augmented reality testing, that can be done as remote work. So you've instructed them, you've given some skills and practice, and as they're working towards the solution, that work is done remotely. And then as they come back to the school, physical printing happens. They're running their machines, the prints are coming out, they're actually putting those machines in testing scenarios. Oh yes, the book Rapid Viz helps students with sketching. Yeah, absolutely. It's useful from this idea of traditional art sketching. And the great thing about the tool that we use, Tinkercad, is that it's not based necessarily on 2-dimensional and then transforming a 2-dimensional figure into a 3-dimensional figure. is based on three-dimensionality from the get-go. So it becomes something that is very, very easy for our students to actually integrate into their practice. But for our students who are burgeoning artists, maybe getting into art for the first time, a book like Rapid Viz becomes a great way to continue to build upon their skills and to jump into other skill sets that become applicable in STEM. For many of our STEM educators, for many of our STEM schools, it's not just STEM, but it's STEAM. Arts becomes a vital component as well. So we talked about flexibility, but what might the example lesson progression actually look like? What might this look like in a virtual instruction section? What we think about is really using a traditional 5E lesson methodology. And what we do with that is then make that applicable to the digital space. So it's not necessarily reinventing the wheel as much as it is realizing that our digital tools allow us to apply what we've been doing in our lesson model, our instructional model, to our students now who are remote and having to do hybrid instruction. It starts with engaging students to solve a real world problem, and that's whole group direct instruction. That's where you guys are building that highlight reel material as you're standing in front of your computers and you've got those boxes with all of your different students. You're engaging them, you're calling them by name, you're even engaging their parents. You're problem solving and you're doing emotional coaching with your students in that moment too. That's where you guys really are rock stars. But something that becomes really exciting, especially as their students themselves become more skilled in their actual digital tools, and they're showing their maturity as digital citizens, is through whole group collaboration. Something that's moderated, your ability to control mics, control who can and can't speak, or having open mics and see how your students are able to negotiate their classroom space, even digitally. That, as an aside, is awesome work. I'm excited for a world in which people are less mean digitally because they had to learn in school how to be better digital citizens. So that's something that's really exciting for me. But something that's also important here is that our students are also able to break out into group chats. For those of us who are really familiar with Zoom and creating these digital breakout rooms, small groups come into the fray, and you as an instructor get to pop in and pop out in your small groups. That's something that creates both this big and little classroom at the same time, something we wish we could do with our physical space. Small group collaboration is what we're talking about when we think about those breakout rooms. When we come back and we're thinking about really your ability to share with our students how the technology works becomes in your moderation. This is where you're sharing your screen as you're live coding or you're live designing and having your students follow along with you. This also becomes a really great point because your students maybe become co-teachers with you if they're designing something like a 3D model of the Sears Tower. Your students may be a little bit quicker than you are with some of these design tools, depending on what tasks are being done. That's something that you get to show to the students and really engage them throughout the course of the class. And then you have your independent work, your remote work, where you're elaborating. This is design instruction. This is you responding to those chats or responding to those emails or messages in Google Classroom or in your LMS. Becomes really useful. Stressful because now you're kind of plugged into your digital devices in more ways than you ever were before. But that remote work becomes the feedback opportunity, your evaluation opportunity, and the now chance to move from your evaluation and assessment into your next part of your curricula. So what we're doing really isn't much different than what we were doing thinking about steps when we were in person. It just has moved into a digital space and requires, once again, these new skill sets from us as we are working with our students. So this is the part where you guys have already been working really, really well. And This I really want to focus on because it has become a sticking point, a linchpin, really, really difficult depending on your situation and your circumstance. You as educators in digital space can also be huge supports to other educators. I personally know educators who I love and respect who have left the classroom in the last 3 months, in large part because we are forced now to use our digital tools and do instruction in ways in which we were never trained to do instruction. Um, I cannot say with more emphasis how important it is to grow in our ability to use our digital skills. Um, Go to all the available professional development sessions for your learning management system, whether it's Google Classroom or Blackboard or Canvas or Moodle or PowerSchool or Schoology or Office 365 or G Suite. You have to know how to use a tool. And if you don't know how to use the tool, that becomes a moment of great frustration, has the potential to really derail what you want to do with your learning goals. It's not fair and it can be difficult, but I believe in teachers to do what literally we've been doing for hundreds of years in the American school system, which is rising to the challenge. The more support that you get, the more confident you feel, that is exuded from you into your instruction and really encourages your students and your parent community to hang in with you as you're doing online instruction. So, whole fire hose of information. We thought structurally about how you might change some things and how you can apply some specific emerging technologies when we think about drones and 3D printing. And I kind of left you with that big bullet point here of making sure that we understand our instructional technology in a way that allows us to teach with confidence and with high fidelity. The next portion becomes this idea of how we can help you at NextWave STEM. And the first thing is actually what you're already doing. You're joining here with us in our webinar series. We will continue this webinar series. This may actually be something that we do into perpetuity. We are really excited about offering extra resources. We're key. I love engaging adult educators and learners and sharing just a little bit of what we do to hopefully make that helpful for you. The second thing that you can do is actually engage us with our product, our curricula, and our training. At NextWave STEM, we develop curricula K through 12 in our emerging technology categories: robotics, drones, 3D printing, and computer science, with a focus on artificial intelligence. Those experiences are hands-on and online. So it doesn't matter if you're in person, you can get the curricula, the training for the curricula, and the equipment to execute it. Those are also in the form of STEM kits that can be developed or actually delivered to your students at home so that they have the technology to be hands-on in your instruction. But we also have the ability to be your instructor. All of our courses are designed so that they can be operated with or without equipment. And our NextWave STEM certified instructors are available to do virtual learning and virtual instruction with your students. That's something that we are doing here in our partner, Chicago Public Schools, this year, and we've been seeing really tremendous success. So you can learn more. There is also going to be a copy of the webinar slide deck that everyone's going to get an opportunity to take a look at. I'll include that in an email. And in that slide deck, when you click on that button that says learn more, it'll open up your browser and take you right to our website. But can't stress enough that you want to make sure that you're thinking about your learning goals in STEM and making sure that you pick technology that has the ability to flex, to be hybrid, to be remote. And we're here to train you in the technology that allows you to do that. Our professional development we are conducting currently online helps you understand the equipment and technology and really customize the course based on your needs. So I'm going to pause for a little bit. I know that was a lot of information. The Q&A functionality is open, and so is the chat. If you have any questions whatsoever, I love getting into the weeds with instructors. I'm going to pause for a little bit and let those fingers start typing for your questions. And there is no such thing as a bad question. Oh, I'm just seeing Mary's comment. Yes, Mary, helping with visual, spatial processing when we think about sketching and design skills. Vital, vital skills. Digital design skills and physical, traditional design skills become really, really powerful for students as they're learning math, and mathematics integrates into all of our other things that we do in STEM. Really, really great comment there. Are there any other questions or comments that you might have? Well, if you do have any other questions or comments, as I mentioned, I love getting into the weeds with instructors. My email is really, really easy. Desmond@nextwavestem.com. You can contact us also at hello.nextwavestem.com. We are on all social media platforms, all major social media platforms, I should say. That's Twitter, LinkedIn, Facebook, and Instagram. No Snapchat, no TikTok. I'm glad TikTok's not banned yet. That allows my wife to get her late night entertainment when I'm busy trying to rest. We may get there one day, but as of now, we are not quite into the TikTok social media space. Email me with any of your questions. Follow-up email from today's webinar will also be from me as well. So you will all receive my contact information. It's also my pleasure to talk about our next webinar. Next week, same that time, same that channel. We will be focusing on how to teach STEM in a culturally responsive manner. Something that becomes really, really critical when we think about making our instruction accessible to student populations. If they're different, if they're diverse, if there are situations where we understand that's something we've been lacking in previously. We want to support you in the ways in which you can make that learning available for everyone in your classroom, and that there's an equitable opportunity for everyone to engage with STEM. I see another question here, or comments here from Mary. Students tend to lose spatial processing, I'm assuming, without handwriting and other art projects. Finding space difficult for many starting students, left-right mapping. Yes, especially at our K2 level, hands-on activity, things that actually get them kinesthetically involved with what we're doing, which is why in-person instruction is so powerful for our students when we think about STEM, are great. We're really excited about the ways in which you can develop those opportunities for students, even as they're removed from our physical classrooms. I've been seeing all kinds of innovative ways in which teachers have been doing that work. Really, really great stuff. But for our participants who are with us today, thank you so much for joining us. That is our time together. We went a little bit fast today, but that's okay. Usually we have more of a crowd. I would like to say to you and wish you all the best luck in instruction as you continue throughout this year. Wishing you safety, both for you and your students and your parents. Be safe as you continue to instruct. Keep working hard and doing the great work that you do. And we'll be sure to see you in our next webinar. So everyone, bye-bye.